Going to start the drawing. This is optional. Really, the next group, the bottom up, the multi-body, and the top down. The focus is on the strategy. But if you want to go ahead and do the drawings for these, there are some interesting strategies or techniques that you need to be aware of. So I decided that since the document template would only carry the predefined views on the first page, and then the additional sheet formats would be without, I'm going to go ahead and do an assembly predefined with just one box and the notes. And then we may take those notes and turn them into a block that we can use on the additional sheets since they don't carry up. I still have to make the decision if I want them in the sheet format and to be permanent or have them flexible enough. So with this predefined view, or if you're using the defaults, you can go to the view palette and pick, or in the drawing, the model view and pick. With predefined view, I'm going to insert model, which takes me very closely to what we'd see with the begin drawing and the begin insert model item, model view. So I'll come over to my assignment. I'm going to bring in the cylinder. It was set to, that view was set to be an isometric, so I've got at least part way. I want to go to per standard before I do anything, make sure that that sticks. And then we'll come down to the scaling, and I'll make it about half scale. And the annotations and positions, not real sure what it's referring there, but sure there are some. So Control C on the view and Control V will show it in the collapse state. And I want to take one of these and put it into the exploded state. Because I mixed the downloaded and the toolbox fasteners, they have a little bit different look, but it's a good illustration of some of the things that we would be looking at, we'd encounter. The tables can only be, the bill of materials container table can only be inserted with an assembly drawing, so we'll go ahead and put that in. The layer that I chose and information that I put in because of the per standard comes in with its attributes, with its colors. Stretch that one out a little bit. See if I can shrink that one in a little bit. Clean this up just a touch. And then make sure you're grabbing onto the four-headed arrow to put it in position. I haven't applied part numbers to this, so I would have to go back and open up each of the parts, which I could do as right-click on the bill of material item, right-click on the part, and we'll go to the custom properties. If these were going to be a little more consistent, so this is 607 and part number 1, I might apply these and put them into the, have them written to the file properties so that things like the modeled by and some of these standard finishes would be set as defaults, but I would still have to go back through and accumulate my part numbers, however that would work. And then we can rebuild. So not sure why that jumped, but let's go ahead, and it got applied. So I guess it got a little bit bigger. Bring that over so it snaps into the anchor. And that looks pretty good on the amount of room. So if I right click and go down to the annotations and then back to auto balloon, that's the same as going up to the annotation tab in the command manager, which is there anything under the S key? We have tables, annotations again. So I also have auto balloons that way. So again, pick your favorite and we'll kind of work from there. All right, so those go in. Don't really like the position of, well, 5's pretty good. Don't like the position of 4. So I'm going to bring 4 back. And if there were, for some reason, a difference between those two bolts, other than the part number from the online versus the description. So one of the things that is always going to be a challenge with ordering is kind of explaining the SolidWorks terminology of the hex cap screw M8 by 1.25 by 30. It's really this information that we're interested in, and picking up that geometry. All right, so we'll need to go through and populate the rest of the materials and the part numbers to kind of complete this out. All right, so keep my fingers crossed. We go to the next sheet. My notes didn't show up, but I'm ready to bring in the parts. So I have to decide how I want to handle those. Bring in the base chamber. And so probably from the top view looks good. And would be looking at having that as a section view. So I'll just put in the isometric. And my center marks, center lines, even my center circle came in as prescribed. Now that switched back over, oh, nope, it didn't. It switched back over to title, so I'm not sure why it did that. So let's use our filters. Window pick, make sure that those are on center. All right, so the problem with having all of these is going to be managing them and making sure that they're playing well. All right, so section view, I'm going to place it at the center so that it snaps into that position. I'm okay with its cut, and we'll go ahead and accept it. Pull section AA out of the way. I think for an A-size sheet that's still too large, but not ready to go into the standard and start changing that. So since that's a little bit too big on the isometric, oh, and that was the sheet scale, not the view scale. So let's go to custom scale on the view and do just the one. All right, so that's looking pretty good. All right, so I'm happy with those. The gasket, because it's a custom gasket, we're probably not going to get away with ordering one of those. We might make that a manufacturer outsourced part to a company that just makes gaskets rather than trying to stamp them ourselves. So the top view, and then off to the side, right view, and that's staying in title. So I'm going to Control Z, escape out of that real quick. See if that will try to catch where that is changing. Or maybe it's, we're going to have one more sheet, so I'm going to see. So it's coming over with the sheet. So if that's traveling with the sheet format, then I'm going to have to save my sheet format, make sure that that's staying current. So one more time with the filters. Let's see if we do a F6. That was the last active. Window pick. So yeah, definitely going to have to go in and update that to per standard. And then F6 again to turn it off. We'll go into the drawing and a projected view. Should have been able to hit the S key and the isometric. And 1-to-1 looks okay there. We'll kind of rough position those. So again, my first pass, my preference is to set all of the drawing views, get a sense of the order of the assembly, and because the bolts are purchase parts, I'm not really looking at how that look like the assembly again. So since I got the hexes in there, yeah, kind of did not want that one, so we'll just delete it out. Now pay attention to which one I'm grabbing. So let's get back in. Nope, it did pick up the cylinder. All right, so cover plate. All right, so since the hex head bolts are purchase components, okay, so the per standard came in with that color scheme. We have the depth. You can place those. And we've been leaving it in inch, pounds, and seconds. If you want to switch over to millimeters, grams, and seconds, that's fine. I think as far as American manufacturing, you're going to find more shops using and being able to communicate in the inch. So if you design in metric, we'll send it out in inch or possibly dual dimension it. All right, so my first pass on the dimensioning. All right, so finish the first pass, we'll go to the second pass. Have a diameter, an inside diameter. I did not have any luck with that picking up the cosmetic thread. It kept wanting to give me a length, where when I picked up the cosmetic thread over here, and the style stayed, so that looks pretty good. And the style stayed with the M8 by 1.25. So keep in mind that these are the smart dimension. I'm going to delete those out and then come up to annotation, go to the whole call out, and we're going to see a little bit different representation. So 6H would probably want to change that. If I remember correctly, the H on an internal thread is 0 allowance. We would probably want to go to a G and update that. So let's see, am I able to get that one? All right, so the through and also a 6H. So we'll have to verify and then see if those tolerances are correct. All right, so what else am I missing here? Oh, the bolt circle. So for the bolt circle, smart dimension, and usually that will get a B period, C period, just to denote that I am calling out for the bolt circle. It's not necessarily a physical geometry. Not sure why it pulled up the radius though, so I would like that to be a diameter. So I'm going to switch it from radius to diametral, hopefully. Oh, that was the outside. No, switch it to radius to diametral. And then the last would be to set the angles. So we have the number 8 times, but then our reference, without drawing another, might be able to pick up the center mark and the center mark. So that worked out pretty good. If for some reason I couldn't, it didn't have the alignment or couldn't get the center mark, I would go to the vertex, the center, and the center, and try that for the angle. All right, so all of that setting my standard seems to be working pretty good. And I looked for, I'm so used to seeing this call out that it still kind of throws me to see just the M8 by 1.25 17 millimeters deep. So when it's attached to the thread, it's assumed the thread length, and really what you're allowing for is the machinist could, if it's not a very efficient use of the drill bits and the machine, but if for whatever reason the machinist decided they wanted to drill almost all the way through as long as it didn't break out, legitimately they could do that, even though it isn't a best practice. So we'll give it an overall height, come to the center, and from a manufacturing standpoint, this is going to be the better measurement. However, that's being opened up. We're not really going to be able to measure from there to there as effectively as taking a depth measure to the step. So we have our shapes in there. That all looks pretty good. I can't think of anything that is jumping out. All right, for the gasket then, we'll do the same types of things. the OD, find a location. When it jumps like that to linear, I'm just going to get it a little closer and find another spot. And after it's placed, then I can get it in a little better position. So that was the outside. We'll go with, I wonder if that's because that's a sketch and that one's going all the way across and back to the value and P.C. Oh, that jumped me out of it. And then the smart dimension for the center. And then if we go to the annotation and pull the whole call out 8 times, let's see if we can do the vertex. Let's see, where is that? I'm going to go back to the smart dimension. So if I can go to the vertex and then to a center and then to a center, that didn't quite work out. So it did pick up something there. I guess the best bet's going to be to have those center marks go between center mark and center mark. I think we've moved away from typical, but I would have to double check that as a note. And since I didn't do it on the other one, that might be time to jump back and say that those are 45 degrees. Typical spacing. And then of course we need the thickness of the gasket. So side view. Okay, I think that gets a good pass on it. And then for the cover plate, and we should be seeing those numbers come across consistently, even at 2 decimal place. The spacing should stay consistent. So whole call out, do the through, and so if for some reason this was to change, or I needed to make these countersunk or put counterbores in them, they would follow the, let's go to smart dimension, they would follow the updated geometry in our settings. Okay, so I don't know why I didn't pick that one, but let's try it again. There we go. Let it catch up and select. All right, so when we think about critical dimensions, the threads with the 6H kind of have their call out. The gasket and the through, really the bolt circle, and that comes back to if we were to do a geometric pass, these would be positional to probably the central axis datum. But I would think that 3 decimal place for the bolt circle would be helpful. And then the inside diameter would be a critical, just so that we're not having a lot of mismatch in alignment. If the gasket compresses and extrudes into the the part a little bit, that should be okay. So let's see, the 236. So let's try and hold that one. That one may be a challenge because of the neoprene and the rubber. In fact, because of the material, we're not going to hold that. So let's just keep it as a document 2 decimal place. And then when we go to the outside, the bolt circle, that would be our critical in 3 decimal places. And then if we were to make another pass, 4th pass, it would be to look at the positional and do we need flatness and parallelism. The standard surface finish should take care of anything that the neoprene can compensate for. And so overall, that gives us a drawing package.